Hello. Hello. Can anyone please confirm whether my voice is audible or not? Please write it in the chat box. Hello. Hello. So, Sahil, can you please confirm whether my voice is audible? Hello, Sahil. Hello. Yash. Yash, can you please write it in the chat box? My voice is audible or not? You can tell now. Hello, Yash.
Yes, ma'am, you are
Hello.
audible.
Okay, okay. Thank you for the confirmation.
Ma'am, but chat option is not available.
Chat option is not available. There is a message, a chat, like there is a symbol for the chat in the top right corner.
Uh,
Like I will show you. Okay, wait. There is a symbol like this. You can see my screen, right?
Yes, ma'am.
Wait, wait. There is a symbol. For chat, there is a symbol like this. Can you see the icon?
Yes, ma'am. I see the icon, but typing option not available at time.
Okay. The typing option is not available. Let me see. Okay, whoever wants to ask any question, I will uh, keep a Q&A section in the last during the last time. Then you can raise your hand and ask the question. Okay. I will disable the mic for whoever asked the question. Now let me mute everyone. Okay. Now, okay. Hello, everyone. So, welcome to the first live section of for the quantum mechanics course. I will in this live section, I will solve some of the questions that will help you understand the topics more better, and that will help you to solve the question that will be given to you to in the assignment. So now it's almost time, so let's get started. Is there anyone here? So let's wait for some time so that everyone can join. Let's wait for 5 minutes. Sahil, do you have any question? Hello? You have raised your hand, so you don't have any question, right? For now? Okay. So I am lowering your hands, okay? So let's get started. So everyone can see my screen, right? Wait. So now I think everyone can see my screen, what is written there. Let me. So now I think you can access the chat box. One of the person had written, I think Rishujit, yes. So whoever have some any query, so they will please write it down in the chat box. I will answer. So for now, let's get started. Okay, so everyone can see my screen. Okay, so can anyone please confirm in the chat box? Okay, done. So let's see the first question. The first question is like a particle in the infinite square well has the initial wave function psi of x0 equal to ax and a minus x in different region. One is uh, from x 0 to a by 2 and another one is from a by 2 to a. So now what is asking is that the what will be the normalization constant a which is given in this function. Okay, so I will start from the basics so that everyone can understand what I am telling. Okay, so now you can see there are so what is the normalization condition? Normalization condition is like when you integrate the wave function psi square dx over the whole space, it must be equal to 1. Okay, so now uh, you see that the particle is confined to from 0 to a region. So from for any integral from minus infinity to 0 psi square dx and for the integral from a by 2 to infinity psi square dx, it will be 0, right? Because in that region there is no wave function, so the probability density will be 0. Okay, this I think this everyone knows. So let's get started. So it will be from 0 to a by 2 psi square dx plus from a by 2 to a psi square dx, which is equal to 1. Okay, now you know that this is like psi square is like psi star x0 dx psi star x0 and psi x0 dx, and this will be from a by 2 to a, it will be psi square 0 psi x0 dx, it must be equal to 1. So now you see that in this different region from 0 to a by 2 and from a by 2 a by 2a, the wave function are different. So that is why I factor out two regions. So this must be a square x square dx plus a by 2 to a. This will be a square a minus x square dx, right? So now you know that if you see the answers now, the answers are all written in real value, like it's 12 by aq, 12 by a square. So we can assume that the a square, that is the normalization constant, it's real. So we can fact. So mod a square will be equal to a square must be equal to a square. This is x square dx and this is x square a by 2 to a. Let's separate out all the variables. Dx equal to 1. So now So now you can see that I think all of you know the integration of x square. So it will be like x cube by 3, right? So then the answer from 0 to a by 2. Now for this one, it will be a square is constant. It will be a square x from a by 2 to a, or this will be x square, sorry, x cube by 3 from a by 2 to a, and this will be minus 2a x square by 2 from a by 2 to a, which must be equal to 1, right? Okay, now if you solve this one, then you will get like, let's solve this one. This will be what? AQ by 24. So this is, I think all of you can solve this one. So if you solve this one, no, then you will get like a square equal to, it will come around, I think, AQ by 12, which is equal to 1. So now the question was asking about a. So a will be root over of 12 by AQ, right? So this is a one of the fundamental question. I think everyone can answer this. Now let's move to the next one. Next question. So I will give you some minutes so that everyone can at least read the question one. Sandeep, you have any query? Okay. Sandeep?
Ma'am, can you wait? Ma'am,
Please tell.
ma'am, can you wait for some time to write down the solution?
Okay, the solution will be, I think, available to you also. Okay. All of the solution will be available to you.
Sorry, I don't understand.
This all
Your voice
solution, no?
is
Okay,
not
write it down. Write it down, but I think solution will be available. All the solution and all this video will be also available to you. Okay, the video link, the PDF file, all will be available to you. Okay, but for now, just understand what I am telling. And if you don't understand anything, I will ask in the last, whoever are having any problem in one of the question, then you can ask them. Okay.
Okay.
Let me disable your mic first. Sahil, you have any question now? Okay, tell me. Tell me, I have unmuted you. I think you are unmuted, Sahil. Just more unmute it from your side. From my side, it's unmuted. I think it's already unmuted from my side, or you can write it down in the chat box if you are having problem. You are not audible. Wait, I have disabled. I have unmuted you. Then hello. Sahil, you are already unmuted. You have any question related to this problem? I think you have to unmute it from your side. It's already unmuted from my side. Let me disable your mic, then enable. Now, can you speak? I don't know where is the problem, but it's already unmuted here. Okay, you can ask the question in the last. So let me solve the next question. Okay. So let's go to the second question. Everyone has read the second question. So the question is the minimum energy and the wavelength of a photon so that it converts into an electron-positron pair will be. So it is asking about what will be the minimum energy that is required to convert a photon to a electron-positron pair. Okay. Now everyone knows about the energy conservation rule, like the energy will be conserved during any kind of process. So we can write it down in this process energy equal to some rest mass energy plus some kinetic energy. Okay. So now you can see the question is asking about minimum energy. So for the minimum energy, we can take the kinetic energy part as 0. Okay. So the total energy will be converted into rest mass energy. Okay. Now you are seeing that a photon is converting into two particles. One is electron, another one is positron. Okay. So we can write it down as E equal to E rest mass of electron plus E rest mass of positron. Now all of you know that electron and what is the rest mass energy? Rest mass energy is given by mc square. So now everyone of you know that the electron positron have same rest mass energy. Okay. So now it will be equal to 2 into rest mass energy of one of the particle. Now for the electron case, the rest mass is like 0.511 MeV. How did you get that? If you put the mass of electron, if you put the value of C square, then you will get this value. Okay, for electron. So now it will become around 0.511, which will be around, come around 1.02 MeV. Okay. Now the question is also asking about the minimum energy as well as the wavelength of photon that is required to convert this to a electron-positron pair. Okay. So we have to find out what is the wavelength corresponding to this energy. Now for the wavelength, you can write it down as Sc by lambda, which will be equal to 1.02 MeV. So now if you put the value of h, which is Planck constant, now everyone I think knows the value of Planck constant, which is 6.6 into 10⁻34 joule second. Okay, if you put the value of Planck constant in the speed of light, then you will get the lambda around 1.2 into 10⁻12. So this is based on the energy conservation rule. Okay. in the fourth question, it is like this. Psi of xt is a solution of a free particle in one dimension with psi of x0 equal to a to power minus a square x square, and the probability amplitude in the momentum space at t equal to 0 will be. So it is asking about the probability amplitude in the momentum space when the wave function is written in the position space. Okay. Now if you the momentum space wave function is given by this equation, like in this one you can see psi of p0 will be written as 1 by root over 2 pi minus infinity to infinity e to power minus I px by h cot e to power minus a square x square dx. It is like the psi of p0 will be equal to 1 by root over of 2 pi integration minus infinity to infinity psi of x0 e to power minus px by h cut dx. Okay. So now put this formula, which is written here, the integration formula, which is minus infinity to infinity e to power minus ax square bx plus c dx equal to root over pi by a e to power b square minus 4ac by 4a. Okay, put this in this form, then you will get psi of p0 is given by a by a root 2 e to power minus p square 4h square by a square. Okay. Now let's move to the fifth question. The fifth question is, I will manage. So the fifth question is the current density for a particle of mass m in a state psi of xt is given by this form. Okay, psi of xt is equal to a e to power minus b mx square by h cot e to power minus I bt. Okay, now it is asking about what will be the current density for this particle which have mass m. Okay, now you are saying that in the question there is no a, right? So first we have to normalize this wave function. So the normalization condition is like this. If you take psi star xt with psi of xt dx, which this will be, and take the integration from minus infinity to infinity, then it will be equal to 1. Okay. So if you put this, now you are saying that the psi of xt is given. Now to find out the psi star xt, you just have to take the complex conjugation of this wave function. So in this wave function, you can see that there is the imaginary term here. Okay. Now this imaginary term will become, instead of e to power minus I bt for psi star, it will become e to power I bt. Okay. So now put this the expression for psi star and psi in this integration, you will get a expression like this. Now this plus IB plus IBT and the minus IBT will become, they will each other, and it will give a value of 1. Now the terms that will remain is e to power minus 2b mx square by h cut. Okay. So now if you solve this equation like the formula, integration formula given here, if you solve it, then you will get a A square equal to 2 bm by pi by h cut. So now the expression for the current density is given by this form. Okay, which gives J current density J equal to h cut by 2mi psi star del psi minus psi del psi star. And if you put the psi star value of psi star here, the value of psi star is like this. Psi is given, so psi star will be, now it's okay, I think, A is about minus B m x square by h cut. Instead of minus IBT, it will become IBT. So now put this whole equation in this. Del psi will be like this. Del psi is like the total right here. Del psi is like dou by dou x of psi. Okay, you just have to take the derivative of the wave function with respect to x. Now psi is given, if you take the derivative, minus bmx square by h cut e to power I by t, then only the x term will factor out here. Okay, so it will give a e to power minus bmx square by h cut e to power I by t with a factor of minus bm. Okay, let me write down here so that everyone can understand. Okay. This is the question. Okay. So psi of xt is given, which is equal to a to power minus bmx square by h cut e to power minus I by t. So now if you take the complex conjugate, it will be like a star e to power minus bmx square by h cut e to power I by t. Okay, only this term changes when you take the complex conjugate. Like which term have I, the complex conjugate part, it will become from minus to, it will become plus. So now if you take the del psi of this, then it will be 2 by dou x of psi. So the final form will be minus bm 2x by h cut psi of xt. Okay, this is for del psi. Now if you look at this formula, and if you put this equation, then you will get a term like this. Now you can see these two terms cancel each other. So the total current density will be 0. Okay. So for this question, the total current density will be 0. Anyone has any question in this problem? So let me solve this question again. I think I have just shown the whatever written I have earlier. So let me explain it in front of you. So now this question is psi1 equal to I phi1 plus phi2 minus a phi3 plus 2 phi4. Okay. Now if you want a this is the bra note. Sorry, this is the Kate notation for psi1. Now if you want to find out the bra notation of psi1, which is given by this, we have to, this is written as the complex conjugation of the Kate vector. Okay. So this will be now in this term, you can see there is a item here. So now this item for the bra notation, it will simply become minus I. All the Kate vector in the complex conjugation will become a bra vector. Okay. Now the Kate phi1 will become bra phi1 plus phi2 minus a phi3 plus 2 phi4. Okay. Similarly, if you want to find out the bra notation for psi2. So just take the complex conjugation part of the Kate notation which is given here. Okay. So if you take the complex conjugation part, then it will come around 3 phi1 plus I phi2 plus 2 phi3 minus phi4. Okay. Now it is saying that these two states are orthogonal. So by orthogonal, we mean psi2 is psi1 will be equal to 0. So now if you take the whole expression, which is given by 3 phi1 plus I phi2 plus 2 phi3 minus phi4 with minus I phi1 plus phi2 minus, it will be plus, it is the Kate notation, right? This one, it will be plus I phi1 phi2 minus a phi3 plus 2 phi4 equal to 0. So, and it is given that these all states are orthonormal states. By orthonormal, we mean phi I with phi j. This is the orthonormal condition. Okay. Phi I with phi j, it will be equal to 1 when I equal to j, and it will be 0 when I equal to j, and it will be 0 when I not equal to j. So this orthonormal condition tells us that the inner product of phi1 with phi1 will be 0. Sorry, it will be phi1 with phi2 will be 0, or inner product of phi1 with phi3 will be 0, or the inner product of phi1 with phi4 equal to 0. Okay. Now if you take the same, like when I equal to j, it will be 1. For all the three cases, it will be 1. 3, 2, 5, 3 or 5, 4. So look at this condition and implement it in this equation. Okay. If you implement in this equation, you will get, like, will be 3i plus I minus 2a. This is only these two terms will be non-zero when they will take a inner product. So minus 2a minus 2 equal to 0. From this equation, you will get 2a equal to 4i minus 2. So a will be 2i minus 1. So I think all of you has understand what I am telling. So this is let's move to the next question. So this is the previous question that I was talking about, like psi of x0 is given to you, which is given as a e to power minus a square x squared. Okay, this is the expression for the wave function in the position space. Now it is asking about what will be the probability amplitude. The probability amplitude in the momentum space. So to get the probability and amplitude, you can see here I have written one formula, which is this. Okay, psi of P0 equal to this. Now put all the expression in this equation and you will get the final expression instead. Okay, let's move to the next one. Okay. So the next question is like for one-dimensional system which is described by a symmetric potential energy with property Bx equal to given Vx equal to V of minus x. Okay. Now it is telling that the energy eigenstate are eigenstate of parity operator. So parity operator is a quantum mechanical operator. If it is represented by P. So if a parity operator operates any kind of state like psi of x, it's just reflects its origin. Like if it is at the wave function is peaked at psi of if the wave function psi of x is peaked at, let's say it is peaked at x equal to 2, then by parity operator use means it will translate this function to x equal to minus 2. Okay, like if you operate a parity operator on any kind of state, then it will give psi of minus x. Okay. Now, if instead of psi of x, if the quantum state is a function of both x and y, then it will become minus x minus y. Similarly, if parity operator operates on a quantum state with psi of x, y, z, then it will take it to minus x, minus y, and minus z. Now it is telling that the energy eigenstate of psi nx. What are the energy eigenstate of psi nx? Will be represented as Enx. So, and it is telling that this energy eigenstate are the eigenstate of parity operator P. To check whether it is the eigenstate of parity operator, we will what we have to do is operate this parity operator on this wave function. Okay, like if the condition is like this, if you take the commutator of with sign of x, if it is giving 0, then you can tell that the parity operator P is a energy eigenstate of this Hamiltonian operator. Oh, okay. Now everyone know what is Px. What is the commutator relation of Px? It's like Ph minus Hp. Okay, it's like if you take AB, then it will be AB minus BA. So you have to just find out whether this relation holds or not. So for that, if you open it up, then it will be like Ph minus Hp sin of sin x equal to 0. Now open this equation, means take this sin of x inside. Hp sin of x equal to 0. Now we know that if the P operator, if it acts on a sin of x, then it will give sin minus x, right? So now the equation will become P. What is H? Let me first know what is H. H is given by minus h square by 2m dou square by dou x square plus v of x. This is the expression for the Hamiltonian. Now if you take this expression, then h sin of x will be equal to minus h square by 2m dou square by dou x square sin of x plus the potential term sin of x. Now in the first term, after the Hamiltonian operator, the parity operator is also acting on this resultant. Now if you act the parity operator on this state, sin of x, then all the x term will become minus x. So here it will become minus 1 dou square by dou x square will be x square when x goes to minus x. This will become sin of minus x plus v of minus x sin of minus. This is the term for the first one. Like for this term, we are getting this. Now coming to the second term, you can see the second term is in the second term. You can see first the parity operator is acting on the wave function. Okay. Now after the wave function parity operator, the Hamiltonian operator is acting. So the parity operator, when it acts on sin of x, will give sign of minus x. Now when the Hamiltonian operator, when it will act on minus 6, it will give, just post the expression for Hamiltonian here, square by dou x square plus v of x sin of minus 6. Now if you take the wave function inside the bracket, you will get sin of minus 6 plus v of x sin of minus 6. Okay, this is the term you are getting. Now, in the question, you can see that one additional condition is given, like with property v of x equal to v of minus x. This is given to you. So, in this equation, you can write this v of x is v of minus x. So, the total expression will be 2m 2 square by dou x square minus minus x plus v of minus x and minus. Now, this is the final solution. Now, if you compare this 1 and 2, you see that they are both equal. So, the resultant will be, the final answer will be pH sin of x equal to 0. This gives us pH equal to 0 because it is a state, right? So, it will not be equal to 0. Any state is not 0. So, the only 0 in this solution is the commutator relation. Okay, pH equal to 0. So whenever this kind of question arises, like prove that it is the eigenstate of this operator, then you just have to see. You just take the, like here it was asking about the energy eigenstates are eigenstate of parity operator. So take the, for energy it is Hamiltonian operator, H, take the corresponding operator. For energy it is Hamiltonian operator and parity operator, it should be equal to 0. If you are getting this kind of relation, then you can say that both are the parity operator is also eigenstate of the energy eigenstate. Okay. And during the solving, while solving this equation, you just have to, like when pH, when the operator is given like this, like pH sin of is, first operate the Hamiltonian operator on the wave function psi first, then operate the parity operator on this. You don't go like this, like first operate the parity operator on this, then operate the Hamiltonian operator. Okay, just according from from right to left, go from right to left. First operator, what is the operator is near to this state, then operate the next one. Similarly, in case of HP, first operate the P operator on this, then operate in the result, whatever the resultant equation you are getting, resultant expression, then operate the Hamiltonian operator on the final state. Okay. So this is one. Then the next question is the energy E equal to 61 E0 for a particle in a 3-dimensional cubical box is 2-fold degenerate, non-degenerate, or 3-fold degenerate, or 6-fold degenerate. What is given? E equal to 61 E naught. Okay, and given E naught is the ground state energy of the particle. So let me recall you what is the expression for the 1D energy expression. The energy expression for 1D is like this: En equal to h squared square by 2m n pi by L square. So the final expression will be n square h square pi square by 2m L square. Okay, now it's not a 1D box, it's a 3-dimensional cubical box. Okay, so similar to the 1D equation, you can write for 3-dimensional cubical box, you can write the expression ENH. There will be 3 terms. So it will be like h squared square pi square 2m square nx square plus ny square plus nz square. Okay, where nx, ny, and z are the quantum number. We start from 1. Now it is talking about the degeneracy. Degeneracy means when two different kind of quantum state, when they have same kind of energy, then you say that these states are degenerate. Like if you see that if you see a 1D case, and if you see the nx square plus ny square equal to let's say 5. Okay, the resultant in this this is for the 2D case, not the 1D case. This is for the 2D case. So how can you get the square of this quantum number is 5? It can be 2, 1, or can be 1, 2, right? So 2, 1 will give 4 plus 1, which is equal to 5, and 1, 2 will also give 1 plus 4, which is equal to 5. So when these two states are called degenerate state, and you are seeing that for this state, you are getting two values like 2, 1 and 1, 2. So in this case, we will say that this state is double degenerate, like two values for this state. Okay. Now the question is asking about a state where the total energy is given by 61 E0. So how can you get E0 is the ground state energy. E0 is like ground state energy is like when the n is equal to 1. So E0 will be equal to h squared square pi square by 2 ml square. Okay, so it will be so E0 in this equation is this. So total expression is 61 E0, which is given by this. Now how can you get the total nx square ny square plus nz square is 61? So for this case, you can see that like if you take is 4, I will take 3 square plus 36 plus 16. It will be 61, right? So we are saying that nx square, ny square, nz square will be 61 when the combination is like 6, 3, 4, and 6. Now you can arrange this 3 state in different manner. Like if you can take 3, 6, 4, or you can take 4, 6, 3, or 4, 3, 6, or you can take 6, 4, 3, or 6, 3, 4. Okay, so you are saying that this state is 6-fold degenerate. So the answer will be 6,4-digit. Okay. Now let's move to the next question, which is given by: consider the wave function for the particle in a one-dimensional box of length L at t equal to 0 is given by this expression. Psi of x t equal to 0 is 1 by root over of pi L sin pi x by L plus 2 by root over of pi L sin 2 pi x by L. So given that the particle is inside a one-dimensional box. So for particle in a one-dimensional box, the wave function are given as root over of 2 by L sin n pi x by L, where n is the quantum number and L is the length of the box. Now let's look at the option what is given. It is in first equation there says that the time dependent wave function psi of x3 is a stationary state. The second one is the probability density is time dependent. And the third one is the time dependent wave function psi of xt is non-stationary state. And the fourth one is probability density is time independent. So stationary states are like those states for which the expectation value doesn't change with time. Okay. Or the probability density doesn't depend on the time t. Okay. So first you can see that first express it on the terms of the normalized wave function, which is given by this. So probability density is like given by psi n of n star xt psi n xt. Okay, to get the probability density, we have to find out what is the psi n of xt and what is psi star xt, psi star xt, and psi n xt. So psi n x0 is given. So first you have to write it in terms of the normalized wave function. It is given 1 by root over of 5L sin pi x by L plus 2 by root over of pi L sin 2 pi x by L. So here we can see n is 1, here n is 2. Right? If you compare this expression with the n term, you will get n equal to 1 here and n equal to 2 here. So now you can the whole expression we can write it down as root over of 10 pi 1 plus root over of 2 by 5 pi 2. Here pi 1 is like root over of 2 by L sin pi x by L, and pi 2 is root over of 2 by L. This is this one only. I have just wrote the whole equation in terms of the normalized equation that you already know. Sin 2 pi x by L. Just use this to normalize wave function and see whether you are getting this expression or not. So to get sin of xt is like e to power minus I is t by h cot sin of x0. Okay. So it will be minus v t by h cot. Sin of x0 is 1 by root over of 10 phi1 plus root over of 2 by 5 phi2. Now take this operator inside. So when the Hamiltonian operator will act on the first state phi1, then it will give e to power minus I e1 t by h cot. And for the second state, it will give root over of 2 by 5 phi2 e to power minus e2 t by h cot. You can see that the wave function is not normalized in this case. So first we have to find out what is the normalized equation for this term, for this wave function. So how can you get the normalization one? You just take the psi star xt with psi n xt and equate it equal to 1 from minus infinity to infinity. So you see that will be a square. A square is the normalization constant. Like this wave function is not normalized, right? So let me write clearly. This wave function is not normalized. So you write it as some constant a, which will normalize this wave function. Okay. Now take this will be a square and this will be psi n star xt psi n xt dx equal to 1. The normalization constant we can take it out. And this will be this will be give 1 by 10. This one will be give. So I think 2, 5, 5 equal to 1. So now you can get the normalization constant value from here, which will be equal to root over of 2. Now express the wave function in terms of this normalization constant. So the final one can be written as xt equal to will be equal to 1 by root over of 5 I1 e to power minus a1 t by h cot plus root over of 2 by 5. Sorry, it's not 2 by 5. Will be equal to root 2 is there. It will be equal to root over of 2 by 5 to e to power minus 2 t by h cot. Now take the find out the probability density for this wave function, which is given by psi star xt plus psi n xt. So psi star xt will be what? 1 by root over 5 I1. The minus item will become plus item. Okay, it was I1 3 by h cot plus 2 by root over 5 phi 2 e to the I e2 t by h squared. Now so it will be psi star is written. Now we write the psi part. 1 by root of psi psi 1 e to the minus I 1 t by h squared plus 2 by root over of psi phi 2 e to the minus I 2 t by h squared. Okay. Now if you solve this one, like take the product of each term, then we will see this will become 1 by 5 and 4 by 5 plus some cross term which have both phi 1 and phi 2. Okay. So this will be phi star, this will be phi 2 star. So now it will become 1 by 5 to 5 phi 1 star phi 2 it was phi e1 minus e2 t by h squared plus another term which you will get to multiply these two terms. 2 by 5 phi 2 star phi 1 e to the phi e2 minus e1 t by h squared. The resultant expression will be 1 plus 2 by 5 phi 1 star phi 2 e to the phi e1 minus e2 t by h squared plus phi 2 star phi 1 e to the phi e minus e1 t by h. So here you are saying that the probability density is depending on time. So you can say that the wave function is non-stationary state and the probability density depends on time. Okay. Now let's move to the next one. So the question is like this: a particle is initially in the ground state of a box of length A. If the wall at x equal to A is suddenly moved to x equal to 2A, then what is the expression for the wave function at position x equal to 3A by 2? So for the particle in a one-dimensional box, you know that sin of x can be written as root over of 2 by L sin n pi by Lx, right? Now, given that the particle was initially in a box of length L, length A, so you can write it down as sin of x equal to root over of 2 by A sin n pi by A x. Now, now x is changing, like x is changing from A to 2A. So this means that this value will change the length part, right? The length part will be changed in this equation. So now the sin of x will be written as root over of 2 by, instead of A, now it will be 2A sin n pi by x 2A. Now, given that the particle is in a ground state, so for the ground state, psi n of x into psi 1 of x, n will become 1. So by putting n equal to 1, you can get root over of 1 by a sin pi x by 2a. Now it is asking about what will be the wave function for the particle at distance x equal to 3a by 2. Now just put 3a by 2 in this equation, root over 1 by a sin pi by 2a, 3a by 2. So it will become 1 by root over of a sin 3 pi by 4 and which is equal to 1 by root 2 will be equal to 1 by root 2. So the final expression will be 1 by root over of 2a. Okay, so answer will be 1 by root over of 2a. Now let's see the next question. This is for a potential barrier of height V0 with finite width A. So it is telling that there is a potential barrier V0 and the width of this barrier is A. And it is telling that the position space wave function psi of x will be oscillatory for any x if and only if the energy of the particle is. So it is asking about what will be the energy of this particle for the wave function psi of x to be oscillatory in this potential when the potential barrier is present. So the solution will be oscillatory whenever the energy of the particle is greater than this potential barrier height. Okay. Otherwise, you will get a decaying like solution. Like if you see you can get it from the Schrodinger equation, which is minus s square by 2m dou square psi by s square plus potential barrier is given psi equal to p psi. Now, if you take to the other side, it will become E minus P0 psi, and you will take it as a constant sum alpha square psi, so dou square psi by dou x square equal to minus 2m by h square alpha square psi. Now, the oscillator comfort equation like dou x square dou square psi by dou x square equal to minus k square psi, you will get a oscillatory solution here. So for this kind of equation, you will get the solution will be some function of cos and some function of psi. For the complete expression, it will be a cos kappa x plus b sin kappa x. Okay. Now, if you compare this equation to this equation, already a negative sign is there. So this term should be positive. So the energy of the particle should be greater than 0 for the solution to be oscillatory in this wave function. So the answer will be greater than V0. Does anybody have any question up to here so that I can answer? Only 10 minutes is there, so I think I can answer some of the doubts you are having till now. If you're having any kind of problem in, okay, Sahil, tell.
Hello. Hello.
Hello.
Yes, ma'am. I had a doubt in question 3, means I was not there in question 3. So could you please repeat that?
Question number 3.
And ma'am, when on which platform are we going to get the recording of this video?
You will get, they will share the link
On mail or on some other
on
platform?
mail. On mail, I think.
So by what time means will we get this?
The details I also don't know, but you will get it.
Okay.
So there is, okay, in the third question, right?
Yes, ma'am.
To this one,
Yes.
consider a was distribution. So for this one, so it is asking about what will be the normalization value of this normalization constant A. So what you have to do is you have to take the integration of this function from minus infinity to infinity and equate it to 1. Okay. So now the A is a constant. You can take it out from the integration. The only remaining will be minus alpha x minus a square dx equal to 1. So now you can make a substitution like x minus a equal to t, then dx will be equal to dt. And if x is varying from minus infinity to infinity, then t will also vary from minus infinity to infinity. So just put this condition here. A minus infinity to infinity minus alpha t square dt equal to 1. And the value of this integration is root over a pi by alpha equal to 1. So you will get, sorry, it will be a square. Sorry, not a square, it is a only. This is a here. A root over pi by alpha. So a will be root over alpha by. Okay. Sorry, the answer will be this one. Okay. You don't have any other doubts, right?
Yes, ma'am. Thank you, ma'am. That was my doubt.
Okay. Anyone has any doubt here? This study material will be shared with you, like whatever the details of the solution will be given to you, and the video link will also given to you. Okay, don't worry about this. If any of you don't have any question, then I will solve one other question. Is this one. So the question is like this: for a particle bound inside a one-dimensional symmetric double-well potential, which is given by this expression Bx equal to V0 within this region, and it is 0 within this region and infinity within this. Now it is asking about whether the ground state is non-degenerate and discrete. So now if you plot this schematic of this potential, then you will get that the potential is like this. It is 0 up to here. It is V0, then it is 0, then it is become infinity. So in such case, the ground state will be non-degenerate and discrete because for the ground state, n is always equal to 1, right? So the ground state will be non-degenerate and just told it. So this one I have already solved it. The current density for a particle of mass m in this, which will come out as a 0. So the short trick for this solution is like if you are saying that like the psi of xt is given as a e to power minus b mx square h got e to power minus I bt. So here you are saying the x part is real. There is no imaginary term in the x part. So in such wave function, the current density will come out as a 0. Okay. You can do the entire calculation and you will see the same result. But if you're saying that the position part is independent, it's real, it's not imaginary, then we will get the current density as 0. So does any one of you have any question? You can ask now. So for the basics, so if you want to learn the basics, then just go through the book, what the professor has suggested. Just go through it once and solve some of the question. Then you will definitely understand it. Or if you're not understanding, just see one of the YouTube video. Then you will see a lot of YouTube video that is available online. So you can learn the basics from there on. Okay. So I think Thiru, I answer your question. So before ending this meeting, can anyone please tell if you have any kind of question or not? You can raise your hand if you have any question in any particular uh, step I have showed you. So I think none of you have any questions. So let's end the meeting for now and let's see you on next Saturday. I will solve some more questions so that you can understand the concept more clearly. So today, everyone understood what I have wrote, right? Can anyone please confirm in the chat box? Don't worry about the material, you will get it. Okay, so no, none of you have any question, I think. So let's end the meeting now. Okay. Thank you all. And thank you for joining the section. So I'm ending the meeting now.